problem is nodal analysis, and we're going to solve circuits with independent sources in them. In this problem, we're looking for the current I sub 0 in the circuit shown below. We see that we have two independent sources. We have a current source, 4 milliamps, and we have a voltage source, which is a 12-volt source at the top of the circuit. Additionally, we have a number of resistors. There's 5 resistors in this problem as well. So let's solve it using a nodal analysis. We notice that the first thing we have to do with nodal analysis is we have to identify all of the nodes. So let's do that first. We know that there's a node at the upper left-hand corner of the circuit. Going along the top of the circuit, another node, a third node, and a fourth node at the top of the circuit. We also notice that we have a ground node at 0 volts at the bottom of the circuit as well. So we're going to solve this problem using nodal analysis, which means that we're going to use Kirchhoff's current law to find the solution. And in this case, we're going to sum the currents into the nodes. So if we look at node 1, we notice that there's two currents flowing into node 1, the current through the 3 kilo ohm resistor and the current through the 12-volt source. But we don't know what the current is through the 12-volt source, and we can't identify it in terms of nodal voltages. So we would ultimately, if we tried to solve this using Kirchhoff's current law and summing currents into node 1, we'd be introducing an additional variable, I 12 volts, for the current flowing through the 12-volt source. So we'd have the 4 unknowns from the nodal voltages, V1, V2, V3, and V4, and we'd have this additional unknown for the current flowing through the 12-volt source. We can only come up with 4 equations for this circuit, the 4 nodal equations associated with the nodes. So we would end up with 5 unknowns and 4 equations, and would not be able to solve the problem because we have too many unknowns for the number of equations that we have. So in order to solve this problem, we have to utilize the concept of a supernode to solve it. And we use this supernode concept when we're doing nodal analysis and we have circuits where voltage sources are floating between two nodal points where one of them is not a reference node. So in this case, the 12-volt source is between V1, or between node 1 and node 2, and neither one of those nodal voltages are known. They're unknowns at this point. They're variables at this point. So we're going to identify our supernode first. And our supernode is the node that encompasses our node 1, it encompasses node 2, and the 12-volt source, as shown in the dashed line. So that is our supernode. So we're going to write Kirchhoff's current laws about the supernode and the other nodes in the circuit. So we see that the supernode has 3 currents flowing into it. The current up through the 3 kilo ohm resistor, the current flowing up through the 2 kilo ohm resistor, and the current flowing through the 3 kilo ohm resistor at the top of the circuit from right to left. So adding those currents up, starting with the 3 kilo ohm on the left-hand side of the circuit, it starts at the 0 volt minus the V sub 1 divided by 3K. That's our first current into the supernode. We also have the current flowing up through the 2 kilo ohm resistor, which is 0 for the ground node, the reference node, minus V2 divided by 2K. So it's 0 minus V2 divided by 2K. And we have the current flowing from node 3 to node 2 through the 3 kilo ohm resistor. And that's all of our currents flowing into the supernode. So the sum of those is equal to 0. We can also write our nodal equation about node 3. In this case, we again have 3 currents flowing into node 3. We have, first of all, the current flowing left to right through the 3 kilo ohm resistor, V2 minus V3 over 3K. We have the current flowing right to left from V4, or from node 4 to node 3. It's going to be V4 minus V3 divided by 2K. Plus we have the current flowing up through the source, the current source, which is minus 4 milliamps, since the 4 milliamp source is flowing out of node 3. That's all of our currents, and the sum is equal to 0. Now if we look at node 4 on the right-hand side of the circuit, it has two currents flowing into it. First, through the 2 kilo ohm resistor at the top, flowing into node 4 would be V3 minus V4 over 2K. And then the current flowing up through the 1 kilo ohm resistor is going to be 0 volts minus 4 volts divided by 2K, or 1K. So it's 0 minus V4 over 1K is equal to 0. So now we have 3 equations and we have 4 unknowns. We need one additional equation. And our one additional equation is our constraining equation for the supernode, which tells us that V2 minus V1 is equal to 12 volts. So now we have all those. We have V1, V2, V3, and V4 identified as variables in 4 independent equations. So we have a set of 4 equations, 4 unknowns, and we could solve for all the nodal voltages if we wanted to. But in this problem, we're looking for I sub 0. And I sub 0, as you can see from the circuit, is the current down through the 2 kilo ohm resistor on the center left part of the circuit. And so that current is V2 minus the reference voltage, 0 volts, divided by 2K. So what we really need is we need to find the nodal voltage for node 2. That's really the one that's of interest to us for solving this problem. So if we can find that, then we can solve for I sub 0 using our equation that we have stated here. So if you solve for V2 using our set of 4 equations and 4 unknowns, V2 is equal to 2 volts. And using our equation on the left-hand side of our page, I sub 0 will be 1 milliamp.